Alright, so let's talk about evaluating functions. Emphasis on the fun. So, um, evaluate is to determine or calculate the numerical value, according to dictionary.com. Source there. So, we want to evaluate this function h of x for three different values, at 3, -4, and x minus 1. So, what I'd like you to do right now is I'd like you to put me on pause. I'd like you to actually evaluate this function for all of a, b, and c, and then unpause me and let's check our answers, okay? All right, see how you did. So first, I asked you to evaluate h of 3. So when I do that, we should get h of 3 equals 6. For letter B, we would get 27. H of -4 equals 27. And the last one, which is slightly different than the rest, we should have h of x minus 1 is final answer x squared minus 4x plus 6. Now, if you didn't get this answer correct, maybe take a look above my step here and kind of think about how I would have gotten from here to here. But, we want to think about what all of these represent. What does -4 represent in terms of my function? What does 27 represent in terms of my function? For part C, same thing. What does this x minus 1 represent in terms of my function? And just a little hint for you, you want to think about transformations. This is just a different representation. So let's make some conclusions. So based on your answers, or maybe your previous memory, what is the process to evaluate a function? How would you do that? So question here says, what does the answer represent graphically if you're evaluating at a number? So this is kind of like A and B. And then I ask, what about if you're evaluating at an expression? So this is like C. Okay, so go ahead, take a minute to actually think about an answer here and write it down in words. And let's see what you guys come up with. All right, piecewise functions. Let's talk about that. So notice here we have my function f of x, and we have 3 pieces to the function, hence piecewise function, right? Piecewise function would be a function that has pieces to it, multiple functions. So here are my pieces, and here would be the domain for each piece. So for example, this absolute value of x minus 3, we only want that to be defined on the domain of x is greater than 1. So why don't you guys go ahead and put me on pause in just a second, and I'd like you to actually graph it on the graph that's provided for you. And then take a second using, your graph and even using the function itself, evaluate at those three values. And go ahead and state the domain and range. All right, so let's go take a look at this graph that I created. So I tried to color coordinate this as best as I can. So this first part, this absolute value of x minus 3, on the domain x is greater than 1. So you see that over here. Notice that here's where x is 1, and anything greater is where our function exists, our specific domain. In blue, I have part of the piece that's negative x minus 5, so y-intercept of -5, slope of -1. That exists on the domain between -2 and 1. And notice that these have closed circles because those are included. Open circles would be not included. And then the third piece of this piecewise graph would be the quantity of x plus 5 squared, where x is strictly less than -2. So here's -2 all the way up here at 9. Notice that thinking of transformations, this would be left 5, so that's why -5 is my x-intercept, and I have that parabolic shape. So remember, the whole title of this is evaluating functions. So if I'm evaluating f of -7, well, there's 2 things we could do here. One, I could determine from my actual function where -7 falls within my domain and then choose that piece, or go to my graph and find that as well. So f of -7 was 4. F of 1, if I'm looking at my graph now, it's an open circle here and it's closed down here, and the closed circle means that that's where it's defined. So that's why that's -6. And last but not least, f of 3, I go to 3. That one's in the purple zone, so we got 0. And again, I could have done all these things just by strictly looking at the domains of my piecewise function and then plugging it into those pieces. Speaking about our domain and range, you guys learned about, or I guess relearned in our last video. Our domain, remember, we think about that left to right. So even though we do have some of these jumps going on here vertically, you know, we do have our function defined everywhere. So for example, up here, it's an open circle, but it is defined down here. Same thing over here. And you know, I can use this vertical line. Let's see if this will work for me. Green for the Packers. You know, I can use a vertical line if I kind of scan it across. It's defined, it's defined, it's defined, even at -2, still defined right here. Keep scanning across, still defined, and it keeps going on forever, right? So we can think of that. I actually talk about like a scanner method when we think about domain and range. So same thing with range. Now, if I'm scanning, I have nothing down here, but once I hit -6, boom, my range begins, and it continues up until -3. Notice that those are brackets because they're included. But nothing, 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 nothing until I hit 0, and it keeps continuing on to infinity, right? Right, because even though that stops there, this will keep going. Okay, so last example here, let's talk about the difference quotient. So this right here, we have f of x plus h minus f of x all over h, where h does not equal 0 because Siri says we can't divide by 0, duh. This is called our difference quotient. This is going to be so important second semester. We're going to use it all the time. It's truly the basis of what we're going to do. So we're talking about it now. You don't need to memorize this. And quite frankly, we're smart enough here. I'm sure we will anyway, just because we'll have so much practice with it because it's super fun. But at the end of the day, we just need to know how to simplify. So I'll kind of walk through parts of this example with you. Okay. So let's find the difference quotient and simplify your answer for the following function, f of x here. So we're literally going to use this function here, plug in x plus h, and subtract by its function all over h. So let's just decide first and foremost, what is f of x plus h? Well, this actually reminds me of example C from the beginning of this video. Wherever we had an x, we're going to plug in an x plus h. Yes, eventually we will simplify this. Okay, so now that we have that, let's actually put that into our difference quotient. So I'm going to take this right here and substitute it in for f of x plus h. And now notice it says minus f of x. So we need to subtract the quantity of f of x, which is right here. It's given in the problem itself. All over h. So I'm going to put this all over h. Okay, so what I would like you guys to do, this is actually the fun part if you're nerdy like me, is I'd like you guys to simplify this entire thing. So you guys are going to go ahead and put me on pause. When you unpause me, you'll see my work and we'll see if you got the correct answer. Giddy up. All right, so let's take a look at our work here. We left off right here where we plugged in everything into our difference quotient. So if we are expanding this guy, notice here I had to distribute out this x plus h squared. So I have that right here, distribute the 3, and then I have this, and it is super duper important to distribute that negative sign as you can see here. Now everything in yellow would be terms that cancel out, and that's so convenient and nice. It makes everything look beautiful. Then I had to factor out an h from what I had remaining. So that gives me my final answer of 2x plus h minus 3. If you got that, sing a cheer out loud. We're almost done. So let's just make some conclusions about the videos that you have just watched. Domain, that would be all the input values from left to right. Range would be all the output values from bottom to top. Function would be a relation, only one output for every input, and evaluate, that's what we just did in this video. We plug in or substitute in for the input and find an output or transform function. Awesome job. We'll see you guys later.